Okay, these notes are for combining like terms. Now, the first thing we have to talk about is what exactly are like terms. Okay, so the actual definition is terms that have the same variable or variables raised to the same exact power. Okay, so the variables and the exponents are the same. So a few examples of actual like terms: 5x and a negative 2x. Okay, both of the variables are an x and they are both raised to the first power. Okay, if you don't see an exponent there, it's actually a 1. It's just known to be there. Okay, so this is 5x to the first power and a negative 2x to the first power. Another example of like terms: 7y squared and a negative y squared. Again, both of the variables are the same. They're both a y, and they're both to the second power. So those are considered like terms. We would be able to combine them if we needed to. Another example, and these have two variables, which is perfectly fine. So we have a 3xy, and if you notice, these are all being multiplied together. That's why it counts as one single term, because it's all connected by multiplication. So 3xy and a negative 1/2 xy. So again, the variables are exactly the same. Both of these terms have an x and a y, and in both of them, the x is to the first power in both, and the y is to the first power in both of them, which makes them like terms. Okay, so you can have more than one variable as long as in both of these terms, like they are here, the variables are the same and the exponents on each of those variables is the same. Now, three sets of examples that are not like terms: negative 6x and a negative 6y. Okay, these are not like terms because the variables are different. This term has an x and this term has a y, so they are not like terms. 8x squared and 2x. Okay, now in this case, the variables are the same. They're both an x, but they are not to the same power. Okay, their exponents are different. This is an x to the second power, and this is an x to the first power. So those are not like terms. Another example of not like terms are 3ab. Okay, so again, this is one term. They're all being connected by multiplication. So 3ab, and then we have a 5a squared b. Okay, now they both have an a and a b with them, which is good. However, the exponents are not the same. So this a is to the first power, while here the a is to the second power. Okay, so even though the b's are same, okay, the b's are both to the first power, the a's have different exponents, so this is not considered like terms. Okay, so our first example, we are looking at actually combining the like terms that are there. So our original expression is a negative 3x plus 7 minus 2 plus x. Okay, so the first thing that we do is we're going to label each set of like terms with different markings, so that way we can see easily which ones are able to be combined. So we have a negative 3x. The only other like term that it has is this positive x at the end. Okay, now again, if you don't see a value in front of that x, that coefficient, that is known to be a 1. So this is a 1x and a 3x. Now we marked those with double lines underneath. You can choose any marking that you would like. Then we mark another set of like terms. So I have a positive 7 and a negative 2. Those are both just constants, okay, or numbers. So those are considered like terms as well. Now if we actually go to combine them, negative 3x plus x gives us a negative 2x. And a 7 minus 2 gives us a positive 5. So our final answer is a negative 2x plus 5. Example number 2. Our original is a 2x squared plus 5x minus x squared plus 9x minus 1. So again, we're going to go through and label each set of like terms with different markings so that we can tell them apart. So if we start with our first value, we have a 2x squared. The only other x squared term here is this negative x squared. Okay, now again, if there is no value in front of that variable, okay, so there's no coefficient there, that means it's a 1. So in this case, this is really a negative 1x squared. Then we can mark our 5x and our 9x as like terms. Okay, so we put double lines under those. Our final term here then is a -1, and that's our constant, and there happens to be no other constants left over in this expression. That's perfectly fine. We just have to remember to carry this -1 to our final answer. Okay, so now if we start combining, in our boxes is our x squared term. So we always start with the highest power, so the largest exponent. So the 2x squared minus 1x squared is really a 1x squared, or just an x squared. That's fine. You are able to drop that 1 and just leave it as an x squared. Then our next set of like terms is a 5x plus 9x. 5 plus 9 is 14, and the x just carries along to your answer. Okay. So our final answer, we have x squared plus 14x, and then that -1 that was in our original expression has to get carried to your answer. So our final answer then is x squared plus 14x minus 1. Okay, the next example is going to be a little bit differently at first. So we have a 3 times the quantity of a plus b minus 5a plus 4b. So the first thing you need to do is get rid of those parentheses. So I'm going to have to distribute this 3 through the parentheses. Okay, so 3 times a is 3a. 3 times b is a 3b. And then the rest of my expression just gets carried down. So minus 5a and plus 4b. Now it's exactly the same as the previous two examples. Now I can go through and label my set of like terms. So I'm just going to start at the beginning of the expression. 3a, its only like term is this -5a. Okay, and that's again because they have the same variable raised to the exact same power. So 3a minus 5a is a -2a. And then my other set of like terms, I have a positive 3b and a positive 4b. So 3 plus 4 is 7, and that b stays with it. So our final answer then is a -2a plus 7b. All right, 2 more examples down here. Again, we have parentheses shown. We have 2 sets of them, so you're going to have to distribute twice. So my 4x gets carried down to the next step. This positive 2 needs to be distributed to the x and to this -3y. Then the -4 needs distributed to the y and the -2. So you have 2 different steps here for distributing. When I do that, again, I carry my 4x straight down. My 2 times x is a positive 2x. My 2 times a -3y is a -6y. Be sure to use the sign that's in front of the value. So this subtraction, this negative sign, gets carried along with that 3. Then I have to distribute a -4. So again, the sign in front of the value is attached to it. So -4 times y is a -4y. Then -4 times a -2 is a positive 8. Be very careful with that. Pay attention to the signs that are with each value. Now it's exactly the same as all the previous examples. You can go through and find your sets of like terms. So if I look at my first value here of 4x, the only other term that has an x to the first power with it is my positive 2x right next to it. So 4x plus 2x is a 6x. Then I have a -6y minus 4y. -6 minus 4 is a -10. So I have a -10y for my next value. If you are unsure when it comes to those negatives, do not guess. Use your calculator. -6 minus 4 is a -10y. And then our final term is this positive 8, which is our constant. It doesn't have any other like terms, which is fine. You just have to remember to carry that down to your final answer. So now my final answer is 6x minus 10y plus 8. All right, one more regular example, and then we will move on to the word problems. So we have 5a squared b plus 4ab squared minus 7a squared b plus ab squared minus 2ab. Now, this has a lot of variables. and a lot of exponents. You need to really be careful with these and take your time. We want to make sure that the variables and the exponents match exactly in order for them to be combined. So my first term is a 5a squared b. So I need to check and see if there's any other terms in this problem that have an a squared b, and it has to match exactly. This term does not. This term I have as negative 7a squared b. So this is my like term with it. Nothing else in the problem is exactly the same. Okay? So 5a squared b minus 7a squared b. Again, you are just combining those coefficients out front. So 5 minus 7 is a negative 2. And then the a squared b gets attached to that value. Okay, now I'm going to look at my next term, 4ab squared. Okay. The only other term here that has an ab squared is right here. There is no value in front of that a, but remember, when you don't see a value there, it is really a 1. Okay, so if it helps you to rewrite it or to put a 1 in front of there, then do that. So it's the same as a 1ab squared. So now if I combine these values, I have a positive 4 plus 1. So 4 plus 1 gives me 5. And then my ab squared just gets attached to that value. Okay, now my last term, so I've used these first 4 already. So all I have left is this negative 2ab. It doesn't have any like terms. There's nothing else with an ab with both of them to the first power. So that's fine. You just now need to put that with your final answer. So our final answer then is a negative 2a squared b plus 5ab squared minus 2ab. Okay, so really take your time with those ones and be careful. Okay, now 2 word problem examples. So we want to write an expression for the perimeter of the rectangle below. Okay, so you need to be really careful with these and make sure you're reading the directions. I need perimeter. So perimeter is the distance around an object. Okay, that just means that we're going to add up all of the sides. Okay, distance around the object means you need to add all the sides. Now, it only gives us 2 sides originally. You need to use the directions and some prior knowledge in realizing that a rectangle, the opposite sides are congruent, okay, which means they are the same length. So if this is 4x, then the opposite side is also a 4x, so you need to fill that in. Then if this long side is 5x minus 1, so is the long side that's opposite of it. Okay, now that you know all 4 sides, you can write it out, and we're going to add them all together. So 5x minus 1 plus 5x minus 1 plus 4x plus 4x. When you combine your like terms, 5 plus 5 plus 4 plus 4 gives you 18x, and a negative 1 minus 1 is a negative 2. So your final answer is 18x minus 2. Okay. All right, last one. We want to know what term must be placed in the box if the expression, so this long expression is what was originally given to us. It's telling us that it's going to simplify to 4x squared plus 5x minus 9. So we need to decide what was missing in the original problem that would give us this as an answer. Okay, so if you start comparing, I have a negative 5x squared and a 9x squared in my original. Okay, those are my like terms. If I combine those together, that's going to give me a positive 4x squared, which is exactly what I needed in my answer. So that can't be my missing term because what I had originally gives me exactly what I needed for my answer. So then I move on. I have a positive 7x right here. I have no other like terms in my original problem to combine with that. But in my answer, I needed a positive 5x. So somehow I went from 7x to a 5x, which means I had to have subtracted a 2x in there. So a negative 2x is what was missing in my box. Again, this is combining like terms. This is your concept number 4.